Homework Hotline, what is your emergency?
Hi everyone, and welcome to the Ghostbusters Hotline.
Sorry, go ahead.
As always, we are here for all of your ghost-busting needs.
If by ghostbusting you mean homework help, then yes, we're who you're going to call for all of your ghost-busting needs.
So we're here live every Tuesday and Wednesday from 4:30 to 5:30. We love it when you call in to ask about your homework questions because we can walk you through the problem. If we need to clarify something, that way we can ask you directly. Our number, if you want to call us, is 720-424-1666.
And we have a few ways you can watch us live on Comcast Channel 22, Prism TV Channel 8007, YouTube Live at Denver DPS TV, Facebook Live at EG Homework, or live stream at livestream.com. Just search for DPS TV 22.
We're here to help you with math and science. I'm Becca. I can help you with math. Sitting next to me is Nathan. He can also help you with math. Over at his own desk is Sam. He can help you with science. Nathan and I teach at Emily Griffith High School, and Sam teaches at Contemporary Learning Academy. Our two schools sponsor the show.
And it's late October, so we are having a Halloween-themed show today, as you can see from my elf hat. We all know that candy lasts quite a while because it has preservatives. Do you know what else is preserved and lasts a long time?
What?
Mummies. That is one of the things our guest will talk about today. Our guest today is Jennifer Moss-Logan, the museum educator at the Denver Museum of Nature and Science. They currently have a mummy exhibition at the museum, and Jennifer will be on a little bit later in the show.
Well, that's just spooktacular. You know what else is spooktacular?
I don't.
Calling in your questions, as I mentioned before. However, we know that calling in is not always the easiest thing to do, so we do have somebody monitoring social media. Jeff, why don't you tell us a little bit about yourself?
Hello, I'm Jeff. I'm an intern here, and my mask, you can tell it's kind of, I don't know, it's similar to my face, but it's a little different because it's a little scarier today. So
It's very realistic.
Really?
Yeah,
oh,
it's
thanks.
It really is.
Yeah, it's like one of those Hannibal things where you can sew it on. No,
Oh,
just
yeah,
kidding.
like face off or something?
Yeah, but no, I'm our social media person, so we'll be taking care of your social media needs. I'll be answering the questions on here, and the trivia question as well, because we have a great trivia question today, and let me give that to you in just a second here. All right, how much are Americans projected to spend on Halloween in 2016? That is our trivia question. How much are Americans projected to spend on Halloween in 2016? So if you guys have the answer, bring it into us.
I did hear what half of the costumes are supposed to be this year. Like 50% of all costumes sold are Star Wars costumes.
Star Wars.
That is what I've heard. Isn't
Because
that
of
interesting?
Rogue One coming out? Or?
Because of Rogue One, I think the popularity of
Yeah.
7 and all that stuff.
Picked
I
up,
actually
yeah.
had a feeling when for some reason when I was watching it this summer, I was like, ooh, I bet a lot of people are going to do
Oh,
this
yeah.
for Halloween. I totally
Probably
thought
be
that.
a lot of politician ones, too.
Yeah, makes sense.
So
makes
many
sense.
Hillary Donald Trumps walking
Yeah.
around.
Yeah.
So many.
Well, Jeff mentioned that he would answer your questions via social media. He would send them on over to us. So let's give you that information right now. You do have our phone number already, but if you would like to send your questions over social media, you can send it through Facebook or Twitter. That's at EG Homework. You could text your homework questions in. The phone number is on the screen. It's 970-680-3771. And if you wanted to email us, you could do that at homework@emilygriffith.edu. So feel free to turn in your homework questions on that, or you could also send in an answer to that trivia question if you think you know. Speaking of the answer to the trivia question, we also, just to mention, we do have a prize for whoever can answer the trivia question, and that is 2 symphony tickets to the symphony of your choice. So by 5:30, get an answer in, and hopefully you can win some symphony tickets. So let's go to Jeff. Let's get some questions. Let's see if he can answer or send some questions over to us from social media.
All right, cool. Well, we have the questions here, and actually we got one on Facebook. We're going to start off with this one on Facebook. It's sent to us by a guy named Don Pierce. He's a really nice guy. I know him. And here, this is kind of an interesting math question. It says Dracula has 12 six-packs of blood. He wants to have a party on Friday night and wants to have 20 vampire friends over, but he doesn't know if he has enough blood so everyone can have 4 apiece. Does he have enough blood? If he doesn't, how many more six-packs of blood does he need to buy?
All right.
6 packs of blood.
I didn't know they sold them in 6-packs now.
Yeah, I thought they were only 24 packs.
Oh, wait, is my pen not working?
Uh-oh. Maybe
Special.
I should take this
Yeah,
one.
why don't you take this one?
I'll take this one.
All right.
So could you give me that information
Yes,
one more
I
time?
can. I can.
Jeff, I'm sorry.
So Dracula has 12 six-packs of blood. He wants to have a party on Friday night and wants to have 20 vampire friends over. Let's see here. But he doesn't know if he has enough blood, so everyone can have at least a 4-piece.
So
pack.
20 vampire friends?
Yeah. So 20 vampire friends, and he wants to make sure he has enough blood so everyone can have 4 apiece.
And each
then-
of these vampires want 4 apiece?
Yeah,
And he
and-
wants to know if he has enough.
It says, do they have enough blood? If he doesn't, how many more 6-packs of blood do they need to buy?
Ah, okay. All right. So he's got 20 friends. He already has 12 6-packs of blood. And they want 4 cans of blood apiece?
Yes.
I guess, okay. So let's actually first figure out how many cans of blood we have first. And then we can also figure out how many cans of blood we need, and we can compare those to each other, and then find out how many more we need. So if we have 12 6-packs, that means we have 12 groups of 6. And when we're doing groups of something, we're multiplying. So I'm going to do this in red since it's blood. So we have 12 6-packs of blood. So all together, if we were to count the cans of blood, there would be 12 times 6, which would give us 72 cans of blood. And so this is how much we have. We have 72 cans of blood available for this very spooky party. And the 20 vampire friends, they want 4 cans, I guess I should say 4 cans of blood apiece. And so we want to find out how much they need. So if I multiply again, so 4 per person, or not person, I'm sorry, vampire, 4 per vampire, we're going to multiply those together, and it looks like we're going to need 80 cans of vampire blood. So we almost have enough vampire blood to feed all of the vampires, but not quite. We need 80. We have 72 and we need 80. So what we need to do is we need to find the difference between what we have and what we need. So to find the difference, we are going to subtract. So we'll subtract 80 minus 72, and it looks like we're going to need 8 more cans of vampire blood. And since vampire blood only comes in 6-packs, if we bought 1 more 6-pack, that would not be enough. That would not take care of it. So we might have to buy 2 6-packs of vampire blood, which we'd end up with 4 extras. Maybe we can invite another vampire friend, I guess. So if we were converting back to 6-packs, we'd say 2 6-packs of vampire blood. That was a fun question. So, Don Pierce, you are going to have to buy 2 more 6-packs of vampire blood to make your vampires happy at your party. Hope that helps. That was a fun question. All right, well, I guess let's go get more questions.
All right, let's do it. Let's go back over to the email over here. And this is kind of an interesting question. This is probably directed at Sam over here. Says, what are some of the possible environmental disadvantages to a hydroelectric power source such as a dam? Everybody talks about hydroelectric power and how we need to use that, but what are some of the possible environmental disadvantages to using?
Absolutely. So really famous case studies of this are going to be like looking at the Hoover Dam or the Glen Canyon Dam along the Colorado River, two massive dams, particularly the Hoover. The hydroelectric power from the Hoover Dam provides a huge amount of the electricity. I don't know the percentage, but it's a large amount of the electricity to Las Vegas, the city. And hydroelectric power is really fantastic in a lot of ways. As long as a river is running, it really seems like, well, why wouldn't we just dam up the river and use that force to turn a turbine and create electricity? The major environmental impacts essentially come from the way that damming up the river changes the environment, or the living environment for the different organisms that might be in that location. So, for example, the very obvious thing is when you dam up a river, you're going to flood a huge section of valley or canyon. The Three Gorges Dam in China is another really famous example of this in China. It's another one to look into. So the first thing you might think about is, okay, so water is just going to cover a massive expanse of land that was once exposed. So anything living up, any land-dwelling creatures, organisms living in that area are going to be drowned or going to lose their ecosystem. From a human perspective, like when they flooded the area for the Glen Canyon Dam and created Lake Powell, they destroyed a settlement town called Haight in Utah. And obviously they told the people of Haight evacuated, but it was a town. It was a home to some people, and they were essentially told, you got to get out of here. We're going to flood the dam. From a personal perspective, there's a lot of beautiful, wonderful hiking that was destroyed when the dams went in. But there are really big, long-lasting environmental impacts of damming rivers also. So put aside all the immediate impacts of just flooding an area. There's a couple big things that happen. So one is rivers act as movers of earth from a continent to an ocean. So while we maybe don't think about it because it's not so obvious because you don't see it happening quickly, rivers are essentially used to take mountains and break them down and carry all the rock in the river out to the oceans. Over time, what would happen is silt would naturally be transported downstream, and you would have like the rivers in the Rocky Mountains are essentially emptying out rock from the Rocky Mountains and flattening slowly the Rocky Mountains. And stopping that essentially stops sort of the natural river formation downstream, can prevent natural silt deposition that should happen downstream that might do things like, for example, create land in a river delta. And then you also have issues with the temperature of the water. So like if a river is flowing without a dam, it may be a particular temperature, whatever it is, and the fish and the different organisms that live in that water are used to that temperature, and it's fairly consistent as it moves down the river. Now you dam the river in one place, and what you're going to do, you're going to stop a bunch of water in a lake, and the water at the top of the lake is going to be slightly warmer than the water at the bottom of the lake, but you're typically going to be letting water out of the bottom of the lake into the river, and so you're going to be letting this freezing cold water out of the bottom of the lake. So like this happens on the Colorado River, the water that comes out from below the Glen Canyon or the Hoover Dam is much colder than it would naturally be if the river was just allowed to flow, which has massive impacts on fish populations, insect populations, bacterial populations, plant populations downstream. And then this is all not to mention just the keeping of water from people and organisms downstream. So if there were people and organisms downstream that were planning on using that water, suddenly they have less access to it because you're restricting it. And this gets into big political and national questions about, is it ethical for the United States, for example, to hold a lot of our water before allowing it to flow downstream? So long-winded way to say there's a lot of different environmental impacts, and it sort of depends on maybe the angle that you're looking at. If you're going to talk about this in an environmental science class, you might identify a particular organism or area or population or community and ask how are they affected by the damming of the river.
Cool. All right, Jeff, do you have any more questions waiting for us?
I do. I have an interesting math question here. This is, let's see here. This is a math question that has to do with simplifying expressions. And it's by a guy named Tom Hanks. I guess he's a friend of the show. And he wants to know, it says to simplify this expression, 1/4 plus 1/4, parentheses a plus 8, plus 74. Now that is
1 divided by 4
Oh.
times a.
Oh, maybe that's.
It's always kind of hard to.
Oh,
write
it is.
in,
Oh, yeah. Okay, so that's
mathematical
not a fourth.
notation.
That's 1 divided by 4 plus 1 divided by 4 parentheses a plus 8 plus 74.
A plus 8 is the 74 plus 74 in the parentheses? Where do the parentheses?
No, the parentheses ends after the 8.
Plus
think
74.
the-
So if I have, I wrote it down on my screen. Jeff, could you tell me? We'll flash it up on the monitor. But could you tell me if that's the right? That's what it says.
Yes, that is correct. Yeah, that's what that says. Let's see.
Okay.
Yep. Yeah.
I could take it since I've already got it written down here.
I'm wondering if it means, because the way they wrote it, I just pulled it up here, that they mean the a plus
The A
8 should be in the
plus-
denominator. That would make
okay.
more sense, I think.
So
It's always hard to see these notations.
Yeah, it's hard
you know,
because you
it
can't
is.
tell
So
it's-
let's try. So like.
I think that's what it's supposed to be. Because technically, they would put the 1 divided by 4 in parentheses if they wanted it to be 1/4 times a plus
okay.
8. Assuming that they know, like, or that they're aware of the mathematical notation importance there.
Okay.
And then I just think about what we often do in algebra with like common denominators. Just thinking that might be what it needs to be.
Okay. I could do either one of them. So we're thinking common denominators. I mean, that's going to be way more complicated of a problem. All right. So one of the things that I wanted to point out here, and actually since this problem is a little bit different, in fact, it might not be best to distribute the 4 as well if we're going to be combining common denominators. Okay, well, we'll pretend that the expression on the bottom is what we're working on. If it's not, you just call us back and let us know. Sometimes, as Nathan said, it is very difficult to type mathematical notation using a keyboard. So here's a suggestion is you could take a picture of or a photo of the problem if it's maybe in a textbook, especially if it's something difficult with fractions or parentheses and you're not sure how to actually type that. But for now, I'll go with this question and
I'll just give Tom Hanks a call later and let him know that it was a little
Hanks.
confusing. And
Come on, Tom Hanks, your question's confusing.
He's got time on his hand right now.
Yeah.
I think.
So when we add fractions, and I guess I'm going to go to maybe a simpler example of adding fractions and combining terms. One of the things that we need to have if we're adding fractions is we need to have common denominators. That's a must. And actually, I was talking about this on the show yesterday. The denominator is what names the fraction, and so they have to have the same name in order to put them together. What I mean when I say that is 2 oranges plus 3 apples. If they don't have the same name, we can't really put them together unless we change the name to something that's common, like 2 fruit plus 3 fruit gives us 5 fruit. So if you notice this denominator here, actually let's just start with the 74. Because this throws people off sometimes as they wonder, oh, well, that's not a fraction. How can I get common denominators if I don't have a fraction? So any whole number we can put over 1, because 74 divided by 1 still has the same value as 74, so I'm not changing any value here. I'm just giving it a denominator. To get common denominators, one of the strategies is to factor your denominators and then find out, what each denominator is missing. And what you might notice on this denominator, our first one, is it's actually missing this a plus 8. And one of the moves that we can do when we are working with fractions is we can multiply a fraction by the same thing over itself, something over itself. And that's because when we do that, it's like multiplying by 1. So I'm going to multiply both the numerator and denominator by this a plus 8 over a plus 8. And the reason I'm going to do that is, again, to get this denominator, this 4, to be the same as this denominator, to give us common denominators. Then it looks like this fraction in the middle does not need anything else added to the denominator in order to make it the same as the first fraction that we have there. It's already, it has both pieces. And then the 74 over 1, that is actually going to need both of the factors that are there. So we're going to multiply both numerator and denominator by 4 times a plus 8 and over 4 times a plus 8. And that, again, then makes all of our denominators the same. So in the next line here, we're just going to simplify what we have so that our fractions are they're combined and put together. So on the numerator of the first fraction, we have 1 times a plus 8, which 1 times anything is just itself. And then on the denominator, we have that common denominator that we wanted, which is the 4 times a plus 8. Then our middle fraction, we have not changed at all, so we can just rewrite that. And then plus, and the top fraction here, we have, our numerator there, we need to do some simplifying, so we're going to multiply 74 times 4, which gives us 296. And then we also have it times this a plus 8, which I'll do in another step just so it doesn't get too confusing. Now, at this point, we have common denominators, and so when we have common denominators, we can add our fractions together. Our denominator will be the same. So for example, again, if I do 1/4 plus 1/4, we add our numerators and we keep the same denominator. We're just following, with these algebraic fractions, we're following the same rules that we would follow with just regular fractions. So denominator stays the same, numerator gets put together. So our denominator on our new expression is going to be 4 times a plus 8. That's our denominator still from before. And the numerator is now going to be all of our numerators added together. So we have a plus 8 plus 1, that's our second denominator, plus 296 times a plus 8. Now, actually, at this point, I'm going to go ahead, I'm going to distribute this 296 times a plus 8, just so I can maybe eliminate steps. So erasing that there, I'm going to simplify it a little bit more. So the 296 times a would just give you 296a, and then the 296 times 8 is going to give us 2,368. Now at this point, we want to actually simplify that numerator there, combining any like terms. This a can be combined with the 296a. Oh, that color's awful. Let me do that with a lighter color. A and 296a, those can be put together to give us 297a. And then our other like terms, we have 8 and 1 and 2,368. So we have 9 plus 2,368, which gives us 2,377. And that's going to be all over 4 times a plus 8. So one thing that we might want to check is if 4 is a factor of these, and it doesn't look like 4 is a factor because we might want to eliminate 4 and 4. What I'm kind of focusing on right now is this 4 here. Seeing if I could factor a 4 out of this expression on the top here, but it looks like I can't do that, and so this is actually in simplest form. So let me actually write that one more time. 7.
It looks pretty simple, the form that it's in.
Really simple, right? Right. This was 296. Meaning we can't simplify it anymore. You're right. Not very simple, but can't simplify it anymore. So this would be our expression, how we simplify that, if that was the problem that you meant to do. So hopefully that helps. I don't know. Do you have anything to add to that?
No, I think you did a Good job. Thorough job of explaining it and using the example of something simpler. So
Cool.
those, again, just take some practice.
They do, and if you can remember the rules for regular fractions, then that helps, because the rules really are the same. We're just working with variables instead.
I would actually say if you're having a really hard time with this and you have historically had a hard time with fractions, it might be a good idea to just work with fractions for a little while. Because if you understand the properties of fractions, then that's really what you're doing.
It's very true. It's very true. As complicated as these look, they really are not. Again, it's knowing the rules of fractions.
Right.
So.
All right. So I think we have a science question we want to go to real fast.
Sure.
And this is kind of an easy, simple science question. It says, what is the largest internal organ of the human body?
Sure. So when you say largest, probably mean like the area that it covers, or maybe the weight. So the answer to that question is the liver. Liver is typically, if we jump to my screen, I have a just breakup of different organs in the human body. Liver is the one that makes the most sense. It's the heaviest, 3.5 pounds. It also takes up the most space. Brain would be close. Brains weigh about 3 pounds. And then another one people often throw out is like the small intestine, because it's the longest. Small intestines tend to be about 20 feet long. But the liver is the answer to that question. The largest body organ, though, is not the liver if you include external organs. The largest organ in the body, is the skin, technically. Covers like 20 square feet and weighs about 10 pounds.
Wow. Okay.
Quick and easy.
Yeah.
A
lot of skin.
Always forget that it's an organ.
Yeah, we don't think of it as an
Yeah.
organ.
Yeah.
It's kind of gross to think of it as being
It's called
weighing 8 pounds. Yeah,
epididymis?
your epidermis.
Epidermis. Okay, well, that was close. So, my brain only weighs 2 pounds. So.
All right, well, we're going to take a little break. When we come back, though, we're going to hear from Jennifer Moss-Logan from the Denver Museum of Nature and Science. She is an educator there, and we're going to hear all about the mummy exhibit that's there right now. So we'll see you soon.
For Alyssa White, painting was not her first job.
Went to the reserves and ended up going to Desert Storm.
Or even her second.
Then I ended up getting into the financial industry in real estate.
But she had good reason to change after the real estate market crashed several years ago.
Living through that and watching people lose so much and having that bubble burst made me really disenchanted with that industry, because I saw so many people losing everything on a daily basis, and I didn't really want to be a part of that.
As a single mom, financing a new education would be hard, if not impossible. But a good friend told her,
Here is an opportunity through the WIN program, which is Work Initiative Now program. They're sending people to Emily Griffiths for the building trades, and they're pretty much paying the whole thing.
Alyssa jumped at the chance for a new career. And what did she think of the program?
It was an absolutely wonderful program. The instructors that Emily Griffith has are truly artists, in my opinion. It was awesome what they know, what they taught, what they shared. I loved it. It was a 4-month program and got a job.
Right away, she was working.
Now I work at Hegum Lundquist Paint Company.
A family-run business that's been around for quite some time.
My dad started the company in 1949.
Ron Lundquist says at the time not many women were in the painting business.
Very few. In the late 80s, early 90s, that there would be 1 or 2 that would come through.
Now, over 65 years later,
My name is Ruth Ann Lundquist-Zuger, and I'm the president of Hegum Lundquist.
Ruth Ann has strong feelings about women in the construction industry.
Painting is a great industry trade for women because of their skill set that they bring to the table, their organization, their attention to detail, and their cleanliness really helps on a painting job.
For Alyssa, she has found a new calling.
I really enjoy the work. I didn't think I would as much as I did, because it is physically demanding. You come home dog tired at the end of the day, but when people ask at the end of the day, how are you doing? I'm like, I'm dog tired, but I'm good.
And what does she have to tell other women who might be interested in this field?
Oh, do it. Do it, do it, do it.
With the help of Emily Griffith, Alyssa now sees her future with a fresh new look.
Hi, welcome back. We're here with with Jennifer Moss Logan from the Denver Museum of Nature and Science. Welcome to our show. Thanks for coming on and joining us.
Thank you so much for having me. Thank you.
Of course. Could you tell us a little bit about what you do at the museum as an educator?
Sure. So at Denver Museum of Nature and Science, I am one of the educator coordinators, and it's a pretty exciting job. What I get to do is create the kind of programming that visitors and students come to see when they come to the museum. So if you've visited the museum and you've gone to Expedition Health and you've checked out a dissection, or you've gone into Space Odyssey and you've seen an astronaut on the surface of Mars, that's the kind of programming that I get to work on and create. So it's pretty exciting. Yeah.
Oh, so a lot of creating.
Yeah.
Oh, very neat. That sounds really cool.
So are you technically like a museum curator? Do you follow curation for education? Is that kind of your role?
So what's really cool about a museum is there are a lot of different positions you can be, and being a curator is one of them. That's where you are charged with doing the science, with doing research, with having that sort of realm. And then there are those who look after our collections, that's our collections management. Mm-hmm. And then on the public side of things are the educational team. And so that is where I am. So the exciting thing about working at a museum also is that all of those groups come together and work together regularly to create exhibitions such as the one which we just opened, which is Mummies, New Secrets from the Tombs. So that's pretty exciting.
So appropriate.
Yeah.
Good timing for Halloween.
So very much. You're all well dressed for it, absolutely.
Right. Nice.
Put a lot of work into this.
Yeah. I got my mask. I got my
Yeah.
mask. It's here. It just won't stay on. That's all. I tried.
I'm the superhero I wanted to be when I was a kid, but the cape didn't grow with, with my body.
Oh. Well, tell us about the mummy exhibit.
Yeah, absolutely. So this exhibition, Mummies, New Secrets from the Tombs, is about Peruvian mummies and about Egyptian mummies.
Okay. What's the difference? Other than the location.
Yeah, I was going to say, one from Peru, the other
Absolutely, absolutely.
But I'm sure there are a lot more differences than the location. That's what I'm asking.
Yes,
about,
indeed. And this is what visitors come to see. So many of them come for the Egyptian mummies because they've heard about that. Right. They come in and they're learning also about the Peruvian. So Peruvian mummies are actually some of the oldest in the world. They're amongst the oldest in the world, going back some 7,000 years. And they're really very interesting. Unlike the Egyptians, who would mummify, so we all have a picture in our mind of what an Egyptian mummy looks like, sort of a straight board and wrapped. In ancient Peru, there were different versions from different cultures, but one of the ones that we highlight in particular in the exhibition, the Peruvians would put the body into a fetal position and bundle it up with cloth and with beautiful textiles, and then put them into these underground spaces along with all sorts of things that they might need. So for example, there's beer and corn and a few goodies from life and things related to what they did in their lifetime. Because in ancient Peru, the belief was that the dead were sort of amongst you. They didn't go to some far off space or be in some, afterlife. They were with you. And so they had everything they needed with them, and you would go visit them and take them out and have them amongst you for certain celebrations. So it's a really different culture from what we think about with the Egyptians.
That is so interesting. Well, Egyptians, it was, correct me if I'm wrong, it was more of gifts and jewels and lavish things they were buried with, rather than just their everyday materials. Is that correct?
You're very close, and there are many things like that we find in ancient Egyptian tombs. In Egyptian culture, in ancient culture, the idea was that you needed to have your body with you in the afterlife. And so it was all about how you can preserve the body.
I see. So Peruvian mummies are not as well preserved.
They are. This is awesome. You are absolutely getting the kinds of things as you go in, as our visitors get as they go into the exhibition.
Okay.
So the Peruvian mummies The very ancient ones actually did go through an extensive process. It was really very interesting. They would take off the skin and tan the skin and take the flesh off the bones and put stuffing back in there and put them back together with a beautiful mask. That was the most ancient of the mummies that we have, and that process is why we still have them. Later on, a different process was used for preservation, and really the bodies were just wrapped, and they were in such a dry climate. That's what Peru has in common with Egypt, is that dry climate along these spaces where we find these Peruvian mummies along the coast of Peru. And so just the conditions would mummify them inside of those bundles.
Was that purposeful? Do we know if it was purposeful or not, I guess?
Yes.
For preservation, or it just happened to work out that way because of the climate?
And this is a great question that anthropologists ask. And what we believe is the case is that these beliefs probably came from, in the ancient past, bodies that were left out in these conditions would naturally mummify. And so the ancient peoples would see these, and they perhaps developed their belief systems around that. And then in the case of the Peruvians, they began to shift and change how they would honor that process, if you like. And in ancient Egypt, where they likewise saw these bodies naturally mummifying, they really got into this system of really doing things to the body to encourage that preservation. And those are some of the things that I brought to show you today.
Is the hook to take out the brains? Is that right?
Yes,
Through
indeed.
the nose?
Who can resist a great brain hook? And the reason is, if you're going to mummify a body the way the ancient Egyptians did, you need to take out the gooey parts. And the gooey parts include the brain, so inside the dead body, in the face of, so here's the dead body, and you would put this inside up through the nose and sort of swirl that around and pull the brains out. Yes, a little like spaghetti, a little bit like swirling it around maybe like a milkshake, and it's a really interesting process out through the nose. Very appropriate for Halloween.
Sounds like a terrible job.
And then your organs also had to come out because they're also a gooey bit, and the organs would be preserved and go into canopic jars like this, and they would be looked after by one of the sons of Horus. So I brought the canopic jar where we would store the lungs, and so Happy here, the baboon, looks after the lungs.
So were all the organs stored in kind of different containers then?
So there were 4 organs that they took out specifically, and each of those 4 organs was put into a canopic jar. Now that's during a very particular part of mummification history. Other times, other things were done, different processes. And so visitors coming to the museum are going to have a chance to not only see incredible artifacts, beautiful giant sarcophagi, the coffins, and learn about that. They'll also be able to learn about how the process of mummification changed through time in Egypt and in Peru.
Was mummification, was everybody mummified back then, or was it, I know like probably you were mummified better if you were very wealthy, but did they try to like if I was mummified, would they just like throw some toilet paper around me and throw me outside in the dry air?
Well, as we like to say, in ancient Egypt, you got what you paid for, you hoped.
Okay.
Now, this is another great place where we can compare these two cultures. In ancient Peru, in those cultures, it was a much more democratic system. The young and the old, would seem to be across the different sort of social elements, were all put into these mummy bundles and mummified. And in fact, those spaces where they were stored would have members of the same family in them.
Oh.
Yeah, so.
Was mummification still going on in Peru when the Spanish made contact with the Inca, or was it ancient history even at that point?
It was actually going on at the time, and in fact, when the Spaniards came to Peru, how those two cultures came together, it's really interesting to look at how practices today, the Catholic practices today of ancient Peru, reflect some of those ideas from the past. So, for example, I mentioned earlier that the ancient Peruvians would take out the mummy bundles and move them through the streets on festivals, for example. Well, if you go to Peru today and you watch the Catholic celebrations, you'll see the figures that relate to Catholicism now, Mary and so forth, in these figure forms being brought through the streets in a similar way perhaps to the way they used to bring the relatives, the dead relatives who they were honoring. So really interesting to look at all of that.
But by comparison, right, the Egyptian mummification took place in the past and sort of ended before what you could call the modern era in any capacity.
Right.
Like by the year 1500, it's still going on in Peru, but at this point it's no longer happening in Egypt. Is that correct?
So it is very true. They have very different timelines, and sort of the looking back in the more recent past of Egypt, we don't have that same tradition of mummification. But we did have mummification all the way through the Greeks and through the Romans, and so also what you see in the exhibition is you see this change through time. You see the absolute earliest pre-dynastic, some 5,500-year-old earliest Egyptian mummies, and then you see how those changed and the incredible coffins and the beautiful hieroglyphs and the tombs and so forth. So they're great. It's a great exhibition, and we hope that people will come and see it.
That sounds really
I'm definitely going to have to come see it.
You have some great questions.
I've always been so interested in it. I think that's really cool. What else does the museum have to offer?
We have so many things. Also happening right now, we have a great additional temporary exhibition, and that is Extreme Mammals. So Extreme Mammals is free with admission, and when visitors come in, when they first walk into that exhibition, it's very cool. There is this gigantic creature that's like an 18-foot rhinoceros-like creature, and that's the first thing you see as you walk in. And there are all sorts of extreme mammals, the biggest, the longest, the shortest, the smallest, the sharpest, the most claws, all those kinds of things, and some great Colorado connections with our Extreme Colorado, and a cart where they can see some of our most extreme mammals right here from Colorado.
Very cool.
Yeah, so that's another great thing happening.
Gosh, you know so much about all different subjects when it comes to that. Do you get to interact with guests of the museum and explain to them all the information that you know?
So we have just we're so incredibly fortunate here at Denver Museum of Nature and Science. We have an amazing program of folks, of volunteers and staff who help to bring the museum to life every day. I do indeed get to be one of them. And this means that when our visitors, our families, or students come to the museum, they are not only going to see these great exhibitions, they're also going to meet people, have touchable objects such as the kinds of things you see here, be able to interact with visitors, ask questions, bring their homework questions, and be able to dive in. So it's a really, really interactive space that we have. And so, for example, we talked about Astronaut on the Surface of Mars. When your students come and they visit Space Odyssey, one of the things that they can do is they can talk to a future astronaut on Mars and imagine what it would be like to be standing there in the future, looking out at someone doing that kind of work, and ask them anything from, so do you miss your family, to what do you eat, to what are those rocks? So it's a great experience for visitors, yeah.
Oh, that's really cool, that interactive piece of it.
Yeah, actually, I went to the robot exhibit over the summer.
Great.
Did you help kind of set that up, or that was really interactive, a really cool exhibit, yeah.
Good. Yeah, that's a really fun one. We have just an ever-revolving door of temporary exhibitions. And in the case of mummies, it's actually only going to be here for a short time, as is Extreme Mammals. In the case of mummies, we are only one of only 5 places that will be getting that exhibition. So a lot of times, this is sort of your only chance to see it.
Wow.
And how long is that going to be out until?
So that will be here until the first part of February, till February 5th.
Okay.
Yeah.
So
That is pretty
Halloween,
short.
what better time to do it right around Halloween? Come on, right?
And a lot of families choose to come over the holidays and bring their families. It's a great thing, especially with the 2 temporary exhibitions at once. And then, of course, there's also IMAX and Planetarium and the whole rest of the museum. So it's a great place to bring your family.
Oh, that sounds like so much fun. Yeah. What about for students and teachers and education, if we wanted to take field trips there, what kinds of things do you offer?
Oh, we have great field trip opportunities. So we have Field Trip Adventures, which is where students and their teachers can come together and they can combine an exhibition visit with some special sort of custom programs, some special programs where their students can dive in a little deeper and have some extra excitement added to their trip, and it just makes the whole field trip go that much more smoothly. And that, like so many of our things, is really easily accessed on our website, where you can go in and you can find out what's going for education and for school students. So,
So cool.
Awesome. I'm really excited. I think I'm going to take my students in the spring, so I'm very much looking forward to it.
That's great. That's great. So for our general visitors, we also have some additional things that are coming up. We have our SCFD Community Free Days. These are days that are supported by the Scientific Cultural Facilities District Fund. And on these days, there are 12 days a year, we invite everyone to come in. So we open up our doors and invite our community to come on in for free. And so we have one of those coming up in November, and then one in December, and then of course next year as well. And we also have a free night coming up.
Oh.
So that's unusual. So that's for Denver Arts Week. We'll be doing Night at the Museums. And so on Saturday, November 5th, we'll also be opening up our doors as part of a citywide effort. And so that's going to be another great night to come down and check out the museum.
What is the Night at the Museum?
Night at the Museums is the kickoff for Denver Arts Week, where so there are all sorts of things happening in relation to Denver Arts Week, and again, you can go online to find out about that. And amongst it, all sorts of museums open up their doors, and there are events, or there are fun things going on. The museums are open, there are shuttles that go between them, so it's a great chance for families that may not have a chance to go during the day to come and check it out. So.
Oh, that's awesome. That's so cool. So cool.
And that's also free admission. So.
Oh my gosh. And so can you see, is the mummy exhibit included in all of that?
So the Mummies exhibition will be open that night, and so that becomes a great night to see it. There is a small charge for that, and again, you can go online to find out about that. Cool. That would be a great night to come and see the exhibition. And and Extreme Mammals, which is free with admission, is also open.
Awesome. Oh, awesome. Okay. Well, we do have to. We're running out of time a little bit. So, but I could ask you questions forever because it's so interesting. Jennifer, thank you so much for joining us on the show and sharing everything that you have to share about the museum. And you guys go online and go on their website and check out all of these awesome things that the Denver Museum of Nature and Science has to offer. That being said, we're going to take a little bit of a break. We'll see you very shortly.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Welcome back. Hopefully you enjoyed hearing from the Denver Museum of Nature and Science. That was so awesome. Definitely check that out. I would like to give you our contact information in case you still have some questions that need to be answered for your homework. So you can definitely call us right up there, but you can also send in your questions to Jeff so he can direct them to us at Facebook at EG Homework, Twitter at EG Homework, texting us 970-680-3771, or email at homework@emilygriffith.edu. So you still have a little bit of time to get those questions in. But in the meantime, Jeff, what other questions do we have to answer?
Well, we have a very exciting question, and this comes at it from a different angle, if you will. Sorry. But no, this is a triangles angles question, and it says, the question is, we can kind of see right there, I have a triangle with two sides of equal length, and I know the value of one angle is 55 degrees. How do I find the value of the other two angles if I only know one?
Yeah, I can take that one. It's a geometry one. I actually cheated and copied it onto my OneNote screen,
Cheater.
I wouldn't have to draw it because this looks a little nicer how it was sent in. So if you go up to my screen, I have this up. Now, this kind of question or this kind of problem is one that you really have to remember some properties of these triangles. So first of all, I kind of want to point out what we mentioned in this problem was a triangle with two sides of equal length, and that's going to be really important for this. So a triangle with at least two sides that are equal length is called an isosceles triangle. And there are a couple things that we know about that. One, if we have two sides of equal length, we also have a couple angles that are the same. So it's important to note that because if this were not an isosceles triangle, I'll get into it in a little bit, but we would not be able to figure out these angles. So one thing I want to point out is that what we always do when we try to find unknowns is we talk about variables and we label things as variables. We also try to think about all those properties like we mentioned. So we know in a triangle, all angles, and I'm going to use this notation, are going to add up to 180 degrees. And if you remember, this is true of any triangle, whether it's isosceles, equilateral, scaling, they're always going to add up to 180 degrees. That's the first thing that we need to know. Now, problems like this, I think the tricky part that sometimes students get hung up on is when they are comfortable with the idea of, I know that I have some missing information and that I should assign a variable. Well, if you assign a variable and you say, okay, this is angle y, and I want to find these two angles, I don't know either one of them, so I'm calling one of them x, I'm calling one of them y because they are different angles. The problem that comes up is you say, okay, I know all these angles add up to 180 degrees because it's a triangle. So I could write an equation that says this angle, 55 degrees right here, plus this other angle I don't know, I'm calling x, plus this other angle y I don't know. If I add all these up, I should get 180 degrees. Now, the problem with this right now is that I've got one equation, I've got two variables. So in this case, using all the strategies we have for solving equations, it is not possible for me to figure out what either of the angles would be individually. But again, coming back to what we know about isosceles triangles and knowing that these two sides are the same length, well, we know in an isosceles triangle we have two legs of the same length. The base angles are also going to be, so this angle right here and this angle right here, let me highlight that instead of circling it. These two angles are also going to be the same. So whatever angle x is, angle y will be the exact same thing. So what we do, instead of assigning this variable over here that I had highlighted, instead of calling this angle y, well, we know that this angle is the same as this angle over here. So if I'm going to call this angle x right here, I can actually call this angle right here, instead of y, I can give it the same variable because it has the exact same value. So once I know that, I can actually rewrite my equation and say 55 degrees plus this angle that I don't know, x, plus the other angle that I don't know, but I do know that it's the same, should all add up to 180 degrees. So now that I have an equation set up with one equation to one variable, now I can solve this and say 55, combining my like terms here, plus 2x equals 180 degrees. And I'm going to get rid of the degree symbol for now. And then I can just subtract 55, and I get 2x equals 125. And then just solving for x, divide by 2, divide by 2. X is going to equal 62.5 degrees, right? Mm-hmm. So because, again, I know the properties of the isosceles triangle, I know that two side lengths are going to be the same, and the corresponding angles that kind of create those sides are going to be the same. I can assign the exact same variable and come up with an equation that has only that one variable. So hopefully that helps, but again, just thinking, if I know two things are the same, use the same variable to describe them.
Agreed. Or if you know how the angles are related to each other. One angle's 20 degrees less than the other, same thing.
Right.
Try to use the same variable if at all possible, rather than saying x and y.
You could say x and x minus 20.
Exactly. Because one variable is something that we can solve for, whereas two makes it a whole lot trickier.
Yeah, we need more information with two variables, typically.
That's very true.
Yeah.
So,
can I ask a clarifying question? Really
Yeah.
fast? You said isosceles triangles have at least two sides that are the same length. Does that mean that an equilateral triangle qualifies still as an isosceles?
An equilateral triangle is an isosceles triangle.
I didn't realize that.
But nobody ever calls it that because it wouldn't be as
equilateral.
specific. But yeah.
Okay, I was
it's
just curious.
classified.
Thank you for that.
Oh,
Yeah.
I actually did not know that.
Yeah.
Interesting. Okay.
There you go.
Learn something new. Wow. Anyways, Jeff, what's our trivia question? One more time for our viewers who haven't heard it yet.
All right, well, I am going to give you the trivia question, and we're going to provide the answer as well. So, how much are Americans projected to spend on Halloween in 2016? That was our trivia question. So, how much? And the answer is $8.4 billion is what the answer is. That's a lot, man. That blows my mind.
Billion with a B.
With a B, yeah.
That is a lot of money.
Yeah.
Billion with a B. That seems like an awful lot of money
Yeah, it does.
to spend.
Yeah, it's an interesting thing because, I don't know, we have a little info here. It says Halloween is the second highest grossing commercial holiday after Christmas. That number of $8.4 billion is up $1 billion from last year, and $2.5 billion will be spent on candy alone. And that doesn't include November dentist bills or anything like that. You know?
I was wondering how much of that was on candy.
Well, there's also black and orange are typically associated with Halloween. Orange is a symbol of strength and endurance, along with brown and gold. Stands for harvest and autumn. Black is typically the symbol of death, and darkness acts as a reminder that Halloween was once a festival that marked the boundaries between life and death. And you got your Halloween garb on today.
Sounds like mummies. Yes, I did. I wore my orange just for today. I did want to wear this,
Becca's so prepared.
I tried to be, but I can't get my mask to stay on, so I'll just hold it for the rest of the show.
While we talk about Halloween.
Exactly.
That's fair.
Okay, but wait. So think about this. So if we spend $8.5 billion on Halloween, right, and if we pretend that we have 300 million people in the country, which is slightly lower than what we do, that's $28 a person on Halloween.
Wow.
How much do you think we spend on Christmas? I had to look this up.
We got to spend a lot more than that.
Yeah, so 8.5 billion sounds like a lot of money. I mean,
was it like 100
I would love
billion?
that much money. 465 billion.
Woohoo!
Wow.
So $700 per person on holiday gifts and goodies, according to the National Retail Federation. So we spend a lot on Halloween, no question, but it pales in comparison to the amount we spend on Christmas. I was just
We could do
curious.
a lot of math with that. What ratio, blah, blah, blah.
Right.
That's really so interesting, though.
Totally.
Oh, my gosh. Well, we hope you guys have a very happy Halloween, a very safe Halloween as well. Don't spend too much money on all of that. Thank you for sending in the questions. And, don't forget to visit the Denver Museum of Nature and Science website so that you can find out more information about those mummies, by the way. So we're going to have to say goodbye. We'll see you next week again from 4:30 to 5:30. Happy Halloween, guys.